Now let us solve few questions based on angles of a triangle, that is the results which are specially applicable for angles of a triangle only. Now in this question we have to show that sine 2a plus sine 2b minus sine 2c is equal to 4 cos a cos b sine c. Right? So let us start off simplifying the left hand side. We can merge the first two terms because both are positive and sine plus sine, so that gives us 2 sine 2a plus 2b upon 2, that is nothing but just a plus b multiplied by cos of 2a minus 2b upon 2, which is nothing but a minus b minus sine 2c as it is for the time being, that gives us 2. Now we have seen the result for angles of a triangle that sine of a plus b can be written as sine of the third angle, that is c, isn't it, into cos of a minus b. The reason behind doing the transformation is that you see that sine c is the term required in the RHS. So we have to adjust that, and if that is the case then we must also adjust the term sine c in sine 2c. So therefore sine 2c can be expressed using the formula 2 sine c cos c. Correct? So therefore we can get 2 sine c common from both of the terms, thereby giving us 2 sine c into bracket cos a minus b minus cos c. Now once again, if you see, we have got the factor of 2 out of 4 and we also have got sine c. So we have to just adjust now cos a and cos b. That means we don't want any c term to see in the remaining terms. So therefore we keep cos of a minus b as it is, but now we don't want to see any c term. So cos c, which is minus, can be now substituted back with plus cos of a plus b, because that is another result that we have seen. Cos of sum of two angles of a triangle is equal to minus cos of the third angle. Right? And if we look at the bracketed terms, they are nothing but the right hand side of the defactorization formula for 2 cos a cos b. So therefore at the end final answer becomes 4 cos a cos b into sine c, which is the required RHS. Right? Let's go to the next question. Once again in triangle ABC we have to show this particular result. Again we see that on left side we have the angles A, B and C, and on the right side we have the half angles, that is A by 2, B by 2 and C by 2, and we have a constant term, that is minus 1, to adjust. Right? So once again let us start by rewriting the factorization formulae for the first two terms, cos a plus cos b. So that is 2 cos a plus b by 2 into cos a minus b by 2. Okay. Minus, if you observe, somehow we want to bring minus 1, and here we have cos c. If you remember, we can write the formula for cos c as 1 minus 2 sine square c by 2, isn't it? That's the double angle formula for cos. So here now once again we replace cos of a plus b by 2 with sine of c by 2, taking advantage of angles of a triangle. Once again the reason for doing this is sine c by 2 is a required term in the RHS, so we must somehow adjust it. The second term cos of a minus b by 2 remains as it is, we can't change it. Okay, opening the bracket we have minus 1 plus 2 sine square c by 2. So you see we got the term minus 1 which is required, and in the remaining terms if you see 2 sine c by 2 can be taken common. Okay. So we take that 2 sine c by 2 as common, and hence in the bracket what remains is cos of a minus b by 2 plus sine of c by 2 and minus 1 as the last term as it is. So moving on, we have 2 sine c by 2 into bracket cos of a minus b by 2. Now sine c by 2 can be written as cos of a plus b by 2 using the results for angles of a triangle. Minus 1. So simplifying further, we get 2 sine c by 2 into now in the bracketed term we apply the factorization result, that is cos c plus cos d. So that is 2 cos sum of the angles upon 2, that gives us a by 2 as well as b by 2. So once we add and once we subtract, correct? And we know that cos of a negative angle is same as cos of the original angle. So therefore we will get a by 2 and b by 2 as the required angles. And at the end we have minus 1. So therefore when you merge the two terms, that is on multiplying, we get 2 into 2 4 cos a by 2 cos b by 2 and sin c by 2 minus 1. That is same as the required right hand side. So that proves the result, right? Let's see one more important result that can be remembered, that in any triangle ABC show that tan A plus tan B plus tan C is equal to tan A into tan B into tan C. So that's an interesting result, that is sum of tans of all the three angles is equal to product of those same tans. Now here we use one simple fact, that if we consider tan of A plus B, that can be written as tan A plus tan B upon 1 minus tan A tan B, right? That we already know as an identity. Now if we are talking about angles of a triangle, then we can always write A plus B as pi minus C, isn't it? So that is equal to this right hand side. But we know that tan of pi minus any angle is equal to minus tan of the same angle. So that is minus tan C is equal to tan A plus tan B upon 1 minus tan A tan B. And now what we do is we just cross multiply and adjust. So on cross multiplying we get minus tan C plus we get now the product of all the three tans, tan A, tan B and tan C is equal to tan A plus tan B. So therefore taking the negative term minus tan C on the right side, we will get tan A plus tan B plus tan C is equal to tan A into tan B into tan C, which proves the required result.